In this video, we're going to talk about the quadratic formula and how it relates to graphing. We're going to start off by talking about the different parts of a parabola. Now, the first thing that we're going to talk about are our x-intercepts, also known as roots. Whenever you solve a quadratic equation and you find those values for x are actually the x-intercepts of your parabola. And when I say parabola, what I'm referring to is this U-shaped graph. In this case, our parabola is opening downward, but sometimes our parabola can open upward as well. If your parabola opens upward, your leading coefficient is positive. So you have a positive coefficient on the x squared term. If your parabola opens downward, you have a negative coefficient on the x squared term. Now, for the quadratic equation, when you use the quadratic formula to solve a quadratic equation, these x values are your roots. The next thing we're going to talk about is called the axis of symmetry, and the axis of symmetry is basically a vertical line that cuts your parabola in half. Looking at the quadratic formula, the axis of symmetry is negative b over 2a. If I take my quadratic formula and I split it up, my axis of symmetry can more easily be seen right there. Now, the axis of symmetry is right in the middle of our two roots. For the example that we have here, my roots are, I'm trying to get my selector. My roots are at -4 and 0. And you'll notice the axis of symmetry is right in the middle of those. And in this example, we would say the axis of symmetry has the equation x equals -2. It's centered between the roots, and with the quadratic formula, we have our axis of symmetry, and then we're going to add or subtract this amount here. We're going to add or subtract this amount here to see where the roots are. So we're centered around the negative b over 2a. The next thing we're going to talk about is this point right here, and that point is called the vertex. The vertex is the maximum or the minimum value of your function. It's either the very highest point or the lowest point. If your parabola opens upward, your vertex is the minimum. If your parabola opens downward, your vertex is the maximum. I don't know why this went to the back. Okay, there we go. We're back on track here. The coordinates of the vertex, the x value, notice the x value is on the axis of symmetry. So the x value of your vertex is negative b over 2a. The y value of your vertex, we can find that by plugging the axis of symmetry into our function in place of x to see what we get for y. So we're going to say that the y value is f of negative b over 2a. And these are the coordinates for your vertex. Whoops. Let me undo that. Okay. There we go. Now these are the main parts of a parabola, and we are going to graph a parabola using the quadratic formula. So first thing I notice, my leading coefficient is positive, which means my parabola is going to open upward. And I'm going to use the quadratic formula to find the roots. I need to figure out what my a, my b, and my c values are, though. And those are the coefficients for the x squared term, the coefficient for the x, and the constant. So my a is 3, my b is negative 12, my c is 9. Whenever I do the quadratic formula, I like to set it up with parentheses. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then I go through and I plug in these values. What that does is that helps me avoid errors with signs and operations and that sort of thing. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now we're going to go through and simplify. Negative 12, that's 12 plus or minus, this is going to be 144 minus 108 all over 6. That's going to be 12 plus or minus the square root of 36 all over 6, which is 12 plus or minus 6 over 6. At this point, I'm going to break this up into two equations. This is going to be x equals 12 over 6 plus 6 over 6, and x equals 12 over 6 minus 6 over 6, which is 2 plus 1 or 2 minus 1. Now, the axis of symmetry, we said the axis of symmetry was this negative b over 2a part. We can find that right here. This is our negative b over 2a, which turns out to be 2. And so my axis of symmetry is at 2, and my roots are centered around 2. We're going to add 1 and subtract 1 from that, and my roots are going to be 3 and 1. Okay, so my roots are at 3 and 1. The axis of symmetry is 2. Now I just need to find the vertex. We said that we find the vertex by plugging in negative 2 for x. We're plugging in the axis of symmetry into our original function, and we're going to see what we get for y. So I have y equals 3x squared minus 12x plus 9. And I'm going to plug in the axis of symmetry, which is x equals negative 2. We're really just saying, what is y when x, whoops, I'm sorry, that should be a positive 2, shouldn't it? There we go. We're saying, what is y when x is 2? So let's simplify that. We have y equals, this is going to be 2 squared is 4 times 3 is 12, minus 12 times 2 is 24, plus 9. That's going to be negative 12 plus 9. That's going to be negative 3. What this tells me is the coordinates of my vertex are 2, negative 3. Which puts my vertex right there. With this information, my vertex and my two roots, I can sketch my parabola. And that is what it would look like. There's one more thing I want to talk about, and that's called the discriminant. The discriminant tells us how many roots we're going to have. And the discriminant is this piece right here. Now, we know that under a radical, if we have a negative number under the radical, we have imaginary numbers. If I have 0 under the radical, it's 0. And if I have a positive under the radical, we have two answers that we could get from that. So, let me talk about this last piece here. This piece called the discriminant. And really focuses on what's underneath the radical here. If you have the square root of a positive number, then it's going to be negative b plus whatever that is over 2a, and negative b minus whatever that is over 2a. If you have the square root of 0, I'll just separate that here. If the discriminant is 0, then there is nothing under the radical, and we just have negative b plus or minus nothing over 2a. We have just the one root. If you have the square root of a negative number, we have negative b plus or minus something imaginary over 2a. Now graphically, what this means, if you have two roots, your parabola will have two x-intercepts. If you have one root, you have one x-intercept, which is the vertex. And if you have an imaginary number, you have no x-intercepts. And again, we can determine how many x-intercepts you have based on the value of the discriminant, whether it's positive, 0, or negative. And that's going to conclude our lesson for today. Thank you so much.